Hello guys and welcome back. We're going to do question 16 to 20 in this video. Okay, I'll show you again. Well, that's question 16 we're going to be doing in a moment. And this is the test. Okay, Math League contest. And we will be doing question 16 to 20 in this video. We'll be covering all the questions. And I already have covered question 1 to 15 in 5 different tests, in 3 different videos, sorry. Okay, so let's make this larger. I want you to first read question 16, even if you have read it before, just read it again. Okay. So you could pause the video. I'm going to start. Basically, we have all these numbers, okay? And either one, we could have plus or minus for all of them, okay? So for example, this 100 could be minus 100 or it could be positive 100. It's up to us. But the question is, put them in a way that the result will be 0. Okay. So, and then how many ways do we have to put it like this? So for example, my first guess could be, let's just start it with this, 1 plus 2, and then minus 3. And then that's 0 already. And then plus 4, and then plus 5. And then maybe minus it by 6, and so on. So how many ways are there to put all of these and get to 0? So I want to give you the answer. The answer is impossible. There are no such answers. There's not even one single answer that would create this 0. It's impossible. And why this is not possible, we're going to start like this. Let's assume that all of these are positive. See, all of them, up to 101. In this case, what is the total result? What is 1 plus 2 plus 3 plus 4 up to 101? You could pause the video, do it yourself. Well, it's going to be 100, the last number plus the first number, which is 1. And how many pairs like this do we have? We will have this one. We have 101 numbers. So I'm going to multiply it by 101. And then divide it by 2. So what is the result? It's going to be 51, 5,000 and something. Okay. And now, let's see. We want to, from here, start changing these positive numbers into negative numbers, right? So for example, this 4 is a plus 4. If I remove this and write a 0 instead of it, the result will be minus by 4, right? And if instead of the 0, I write negative 4, this would be minus by another 4. So as you could see, the total result will be minus by 8, not 4. Let's see another one. So here in the middle, the next number here will have also 15. It was like a positive 15. I'm going to show you again. So if I clean this, make a 0, again, the total result will be minus by 15. And if I write negative 15 instead of 0, it will be minus by another 15. So it would be minus by 2 15s or minus by 2 4s, right? So it doesn't matter what number I minus it by, it's going to be double. And that double is the key, because the total result will be 51 minus by 2 times any number that you select here. See, I could select 5 and then 7. You would select any numbers that you want. It doesn't matter positive, it doesn't matter odd or even. Eventually, because of this 2, this thing will be an even number. Okay, I think you understand what I'm getting at now. So, but 51 is an odd number. So how can you minus an odd number by an even number and get 0? Impossible, right? So that's a proof why there are no such possibility to add or minus these and get the number 0. Okay, so the answer is no such thing. Let's see. So here is in how many ways, in how many different ways can you do this? In 0 ways. Impossible. Okay, that's question 16, which was, I think, a rather challenging question. And then for question 17, I want you to read the question and pause the video. I want you to read this part now. Okay. And also, okay. Also this part. Yeah, my video is sometimes blocking, so I make it smaller. Okay. So read the question, please. And this part. And that's going to be the final question. Okay, so that's a kind of a longer question. And I'm going to do only one of them as an example, and that's all. But I think the main challenge with this question is the naming of the questions, right? Here, these are simple polygons in red, which are these. I think no problem. But here, some of them are purple and some of them are green. The purple ones we're going to call them star polygons. The green one are going to be compound polygons. So the thing is, just why and how? Because you will create another shape and then you're going to decide if it's a star or it's a compound. Is it green or is it going to be purple, right? That's the challenge. So the green ones, you see why we call them compound is because it's made of the shapes we already know. This is made of 2 triangles. Okay, this is made of 2 squares. Okay, this is made of 3 triangles. Okay, see, all of them are made of the shapes we already know. But is it also true about the purple ones, about the stars? So let's go. If I go like this, and I go like this, and I go like this, okay, you see, if I want to connect the side, I can't. So it's not made of the shapes, the simple shapes we already know. It's not made of triangles or squares or any shape that we know. That's why we would call these stars. Okay, that's, see, the shapes are weird, right? Okay. And then I think that was the main challenge of the question. See, you could pick either one of these, and let's just start. For example, let's go with this one. See, I hope I can do it here, right? So, see, all we have to do is continue these shapes, okay? Let me see, I will do, okay. So all we have to do is continue the shapes like this. And this one like this, and this one like this. Okay, so I'm trying to draw the shape. Okay, so I think you get the idea. This is more like a drawing question, the rest of it. Just have to continue all of these just like this and like this. I think it's complete now. Okay, now we have to name it, right? So that's the next shape. Is it a star? Okay. Or is it a compound shape? So I have to highlight it, look. So if I go from here to here, and then, oops, I can't continue this, look. If I go like this, so this has to be purple. This is actually a star. Okay. And then all you have to do is continue these shapes. Okay, so I'm not gonna do it, but you can do it because it's not gonna be difficult. So, and then we will start. So if I continue this one, and this one will be like this. Okay, I could continue this one and this one. Okay, so we'll create another shape and you just repeat this process. Okay, it's gonna be long, a lot of shapes. Okay, but I think you have enough information to finish the question on your own. Okay. And then for question 18, I think this question wouldn't be really challenging, but we're gonna do it, at least some of it. So read the question, please. Okay, so let's see how I think we could answer these questions. Well, drawing it would be the easiest one and the safest way to answer the question, right? So let's assume that this yellow one over here is the bottom place. So the bottom place, if you look at here, is going to be just yellow. So this yellow one is here. Then this one will be the one on top. So it would be, this one would be yellow. Okay. This one would be yellow with this red in it. Okay, it would be this one. Okay. So in this case, okay, this was on top. So this one would be yellow. If this is on top. This one would be red. Okay, and the same thing goes on. Okay, this one, the top part would be yellow. The bottom part will be red. Okay. And from the other side, okay. So I think we will have enough information now to give the answer, right? So this one cannot be the answer. This one can. This one is yellow. It'll be on top. This one can't be. This one can't be. And well, let's see, from the yellow and the red, this one can't be. So the answer would be this one in the middle. Okay. So I think it's not very challenging. So for the rest of the questions, I'm just gonna give you the right answer because you could do it and then check if we have the same answers. Okay. For, let's see. For this one, the next one, we could draw it, but you could also, this one I think is the right answer. Okay. If you find them challenging and you want me to draw them, just write it in the comments. We could make another video because I assume you could do it. So this one would be the right answer. This one, I think this one is the right answer. For the next one, I think this one would be the right answer. Okay. Just check. Tell me if you have different answers. And then the next question, question 19, is very beautiful, very interesting. Okay, so please read the question. And again, pause the video and read this part. So basically, what does the question say? It says that this person starts from the middle. It could either go left, and then it could go right, and then go again right, and then again go right, and then go back left. You see, that this is how it is. And the question is, what is the possibility that the person would go back to the starting position, right? So for example, here, imagine we start by right. What is the possibility that the person will go back? We need two lefts to do that, to go back to the beginning position. Okay. And one important thing here, it says, assuming that the walk continues indefinitely forever, right? That's, again, a key word here. Like we have indefinite time, okay? And now we have these options. Well, option says definitely the person will go back. Option 2 says 50% goes back. C says it never goes back. That's weird. And D says none of them is true. So maybe it's 85% or something. Also, you see, this thing, how large is this shape, right? This one, how many can we go left or how many can we go right? This is also indefinite. So the path is also forever. It could continue forever. Okay. So I think the model we could start by, what if we have only one step, right? Then we have to go left or we have to go right. So definitely we can't go back. But what if we have two steps to take? Well, the options are right and right. We could go right and left. Okay. We could go left and then right. We could go left and left. See, we have 4 options and 2 of them will go back. This one will go back. And this one will also go back. So 2 from 4, that's 50%, right? So if you have 2 moves, the answer would be 50%. Now, what if we have 3? Okay. If we have 3, it's going to be, let's write it here. If we have 3, I'm going to write all of them. We have right. That's 1 move. And we have 1 right here, 1 right here, 1 right here. Okay, so it's going to be 2 lefts here, 2 lefts here, and 2 lefts here. What if we have what if we have two rights and or one left? Okay, so if you have one left could be here, one left could be here. Oops, one left could be here. So two rights and then two rights, and the last one will be two rights like this. Okay, we also have, did I do left, left, left? No. So we have 8 possibilities here. Let's see how many of them will go back. This one won't, this one won't. We go right and left, this one will. We go left and then right, this one will. We go left, left, and then right, not enough. Left, right, we go back. Right and left, we go back. This one we wouldn't go back. See, I hope it's clear. So for example, if we go this one, so for example, why do I say this one is, we'll go back to the beginning? Because we start by a left, the person will go left, and then it will go person take another step to the right. We're already back. It doesn't matter now if we go left or right, or I'm already back. So again, we have 8 steps, 8 different possibilities. 4 of them went back to the original position. So, and this will continue, right? Even for 4, 5, 6, you could try it yourself. I'm not gonna. And now it's the time to choose with this information. Well, for all possibilities, if you have, for example, 4 steps, 5 steps, the answer is 50%. So I don't think this is true at all. But here, there was one word I mentioned here, that the word it was, we have infinite time, right? So infinite time is what, right? So imagine 1 million years has passed, okay? And we're just taking steps and steps and steps and steps and steps, and we are far away from the starting position. Well, is it possible to go back? Because we still have a lot of time, right? So will it be possible that after 10,000 million times, we eventually will have more lefts, and then we will go back to the beginning, right? Because we have indefinite time. And I want to show you something interesting that I want you to read. I hope you can see it, right? Let me check. Yes. So there is like a, no, not here. I'm going to write like monkey theorem. I want you to read a little about this. Okay. The infinite monkey theorem says, you can read it here, that, okay, if we give a monkey enough time, it could come up with any essays or any written text, or like the video that I have had right now, all the words that I said from the beginning to the end. If we give infinite time, eventually the monkey will type whatever I said during this video. But how much time do we need? 10 million years multiplied by 10 million. Okay, so for that reason, well, I'm going to choose option A, because it doesn't matter. We have infinite time, and then we will go back eventually to the starting point. See, I gave my reasoning. Am I 100% sure that my answer is right? No. Just think for yourself. I explained the 2 ways. I think A makes more sense. Okay, and then the last question here, question 20. Okay, I think it wouldn't be really difficult. N is an odd positive integer, and we're gonna square that positive integer, and then mod 8 equals 3. If you don't know what this means, that's very simple. that it says, what it says is n is squared. We divide it by 8. Well, when divided by number by 8, the remainder could be 0, 1, 2, 3, 4, 7, right? Here it says the remainder will be 3, right? This would be the remainder. R would be 3. That's the meaning of it. So all we have to do is just start by numbers. Like, what is 1 squared divided by 8? What is the remainder? Well, let's go with the remainder will be. Well, when I write it here, I don't mean that. So the remainder will be 1. What if we have 3 squared? Okay, it's going to be 9. And 9 divided by 8. Again, the remainder will be 1, right? So the next one, 25 divided by 8. The remainder is again 1. Okay, I think you know what I'm getting at. So 749 divided by 8. What would be the remainder? Okay, or I'm gonna write it here. 49 mod 8. Again, the remainder is going to be 1, I think. So it's very clear. And then next number is 81. Okay. So let's try a very, very, very big number. So let's go Google a big number together. What if the number is very, very large? 777 multiplied by 777. Okay, when we divide it by 8, what? You see, it becomes 0.125, and that shows that the remainder will again, okay, the remainder will again be 1, okay? So I think that's very clear. So my answer to this question would be there is no such n, okay? Again, if you have a different answer for any of the questions, leave them in comments, okay? That's enough for this lesson. By the way, I got this gift, so that I'm excited about it. So that's why I just put this on today. Take care and bye-bye. See you in the next video.